Welcome to This Explainer. Today we are diving headfirst into the absolute double-edged sword that is quantum technology. We're talking about a technological leap so profound it literally carries both world-saving potential and, to be totally honest, an apocalyptic threat to our modern way of life. This is, without a doubt, one of the most fascinating technological crossroads in human history, so let's just break it all down together. Picture this. It's the year 2035, you're driving to work, and out of nowhere, a complete failure of global encryption locks you inside your self-driving car. At that exact same moment, your bank account drains to zero, your entire crypto portfolio vanishes, and as you're looking out the windshield, the city's power grid shuts down block by block. Now, this isn't some dystopian sci-fi movie. It's what security experts actually call Q-Day, the exact moment quantum computers break the cryptographic foundations of our digital world.
But hey, let's step back from that terrifying scenario for a second and look at the why. Section 1. Dawn of the Quantum Decade. So, why are we racing toward this totally new era of computing right now? Well, as recent industry research points out, Moore's law is coming to an end, and classical computing is reaching its physical limits just as our demand is really starting to surge. We are hitting a wall. For decades, we've relied on constantly shrinking microchips to double processing power, but we are reaching the absolute physical limits of how small silicon components can get. And this is happening right as our need to solve incredibly complex global problems from climate change to drug discovery is surging way beyond what classical machines can handle. To break past those limits, we move to Section 2, qubits, a new reality. To really grasp this, we need to understand what makes these machines fundamentally different from the devices you and I use today. Just think about the sheer physical reality of this hardware. That gorgeous, golden, almost chandelier-like structure is the core of an IBM quantum computer. We aren't talking about a regular microchip sitting on a desk anymore. It is a completely new class of hardware that requires extreme, cryogenic environments, literally colder than deep space, just to operate without outside interference. The crucial thing to understand here is how these machines actually process data. You see, classical computers process information linearly, using bits, which are absolute. They are either a 1 or a 0. Quantum computing, on the other hand, uses qubits. And thanks to the completely bizarre laws of subatomic physics, a qubit can exist as a 0, a 1, or, and here is the kicker, a superposition of both simultaneously. This isn't just some minor software update. It is a massive paradigm shift. By leveraging quantum phenomena like superposition, entanglement, and interference, these machines can calculate a vast exponential number of possibilities all at once. Adding just a few extra qubits multiplies the processing power exponentially. We're talking about solving complex, multivariable problems in a matter of minutes, problems that would literally take today's fastest supercomputers millennia to crack. Because they can map these impossibly complex variables instantly, we reach Section 3, Utopian Solutions to Global Problems. Quantum computers offer almost magical fixes to humanity's most stubborn challenges. Take global food security, for instance. Right now, if we want to create a drought-resistant crop, we have to rely on decades of painfully slow agricultural crossbreeding and endless yield trials. But with quantum tech, we could skip those decades entirely. We could directly compute the exact genetic combinations needed to instantly engineer climate-resilient crops. We're talking about the potential to end global hunger. To really put that into perspective, a single soybean plant has about 46,000 genes. Classical computers simply cannot map the near-infinite combinations of those genes to find the perfect trait. It's just way too much data. But a quantum computer? It could navigate those 46,000 variables effortlessly, identifying the exact genetic sequence needed for absolute maximum yield. And honestly, agriculture is just the tip of the iceberg here. Think about it. The exact same subatomic processing power that maps plant genomes could perfectly model new catalysts for CO2 conversion. It could discover entirely new classes of antibiotics to fight superbugs, or run hypercomplex models to stabilize global financial markets. It is a true technological renaissance. But of course, every massive leap forward has a dark side. Section 4, the quantum cybersecurity apocalypse. You see, the exact same processing power that could save the world could also utterly destroy the digital foundations of our modern society if we aren't prepared. Recent research has shifted this from some distant sci-fi concept into an incredibly urgent crisis. Tech giants like Google have issued stark warnings about an upcoming quantum apocalypse. New breakthroughs suggest this quantum power could break through all modern cybersecurity protocols much, much sooner than expected, potentially before the end of this very decade. Let's break down the math behind this threat. Almost all of our modern digital security relies on something called prime factorization. Basically, taking a massive number and figuring out which two prime numbers multiply to create it. It's a math problem so insanely complex that it would take today's most powerful supercomputers 300 trillion years to crack. But a quantum computer running the right algorithm, it could break it in less than 10 seconds. 10 seconds!
And what's causing a ton of renewed panic right now is this specific number, 10,000. We used to think an attacker would need a quantum computer with millions of qubits to break standard security, like the P256 encryption we use for credit cards and crypto. But a recent study by Oratomic proved it might only take 10,000 qubits to do the job. The threshold for disaster is dropping fast.
Now you might be sitting there thinking, well, these advanced machines aren't quite ready today, so my data is safe for now, right? Actually, not quite. Security agencies are warning that hostile nation-states are actively executing what's called a harvest now, decrypt later strategy. Basically, they are sweeping up and stockpiling massive amounts of secure military, corporate, and personal data right now. The very moment their quantum tech matures, they're going to unlock all of it at once. The realization of this imminent, retroactive threat brings us to Section 5, the race to save encryption. It has kicked off a desperate Y2K-level global engineering mobilization to secure our infrastructure before Q-Day arrives. So, let's dive into the solution. After years of testing, cryptographers at the National Institute of Standards and Technology have approved a new defense called lattice-based cryptography. It's pretty wild. Imagine hiding a secret inside a map of Manhattan, but then stretching that map into thousands of dimensions and flooding it with mathematical noise. It creates a puzzle so ridiculously disorienting that even advanced quantum algorithms just cannot navigate it.
Now, these new algorithms work in theory, sure, but actually implementing them, that creates a monumental logistical nightmare. Because post-quantum encryption requires much larger data fields. That means we have to completely overhaul deeply embedded legacy systems. We are talking about credit card networks still running on 1970s code. It could require physically replacing every single ATM on the entire planet. And, incredibly, we have to figure out how to physically upgrade the hardware on satellites that are currently floating in space.
Which brings us to the ultimate question. The new defense algorithms are ready to go. But will we actually manage to upgrade the world's digital infrastructure in time? Or, when you think about the sheer massive scale of hardware replacements needed and the secret stockpiling of encrypted data that's already happening right under our noses, is the quantum apocalypse already inevitable?